So hello everyone, I'm Jason Mays, and today I'm going to be talking to you about building next generation web apps with TensorFlowJS. Now, I do often get asked a bit about my career history today, just like we just had. So for those of you who are curious, this is kind of my path to where I got to today. So started in computer science, moved into web engineering, then did full stack web engineering. And then at Google, I became a creative engineer or creative technologist investigating emerging technologies, which led me to do prototype engineering for our largest customers globally. And with that, I then realized I could combine my passions of web engineering with machine learning to be the developer advocate for TensorFlowJS. Now, there's one thing you take away from this slide is that I've been playing with JavaScript for over 16 years of my life. So it is my passion, and I hope to share some of that with you today. So first of all, why on earth do you want to do machine learning in JavaScript? That's a great question. And essentially, if we look at the charts here, you can see that 68% of people use JavaScript as one of their primary languages in production. That's a huge number of developers globally using JavaScript. And secondly, if you're using it on the back end in Node.js, over 51% of people choose Node.js as their framework of choice on the back end in production. So even if you're not using JavaScript yourself, other people do, and it's a good thing to learn to integrate with those teams as well. Now, TensorFlowJS is a library for machine learning in JavaScript. And that basically means that we can run anywhere that JavaScript can, which is essentially everywhere. And that equates to zero install on billions of devices globally. And you can just follow a link and it'll just work. And in fact, here's kind of an overview of all the areas we can run in right now. So on the left-hand side, you've got the common web browsers. We've got server-side via Node.js, mobile native via React Native or progressive web apps, desktop native via Electron, and even IoT devices like a Raspberry Pi to get access to those areas too. After all, that's just Linux, essentially. So on Linux, you can install Node, and you're good to go. Now, JavaScript is one of the only languages that can run across all of those devices. So for that reason alone, it's very powerful to reuse your code across the stacks. Now, with TensorFlowJS, you can retrain via transfer learning, or write your own models completely from scratch if you've got the knowledge to do so, if you're from a machine learning background. Just like you might be doing in Python, but of course within the JavaScript ecosystem. And it should be noted, as you can see from this slide, TensorFlowJS is one of the only forms of TensorFlow that can actually digest and run most of the other types of TensorFlow. So you can see here, we can actually take some TF-Lite models, we can take TF Python models and convert them to TensorFlowJS, and even MediaPipe and Onyx, there's routes from there to run in the browser as well. Now, TensorFlowJS is growing exponentially. In just 2 years, it's grown over 10x. We're now standing at close to 100,000 weekly downloads, and that's not including all the cached results, of course, because in the browser, once you've downloaded it once, it's kind of cached, you don't need to download it again. So these are all the fresh downloads every week. And essentially, you can use TensorFlowJS for anything you dream up. And I'd like to share with you some really cool use cases to get you kind of inspired and excited. So the first one is by a company called InSpace, and they are a video conferencing and chat-based platform. And they're using our tech toxicity model to understand if something is toxic before it's even sent to the server. And of course, that's really powerful because you can then save server processing time for messages that are probably toxic to avoid sending them in the first place, and then alert the users of the fact they might want to consider being more polite. Moving on to healthcare, a company called Include Health now enables remote physiotherapy at scale using TensorFlowJS in the browser with a regular webcam. So no special Connect device is used here, just a regular webcam built into your laptop or USB camera, and they're able to provide medical-grade healthcare for physiotherapy remotely. And that's, especially in the current times in which we live, where people can't always go out to places right now due to the pandemic and other reasons, this is a great result for them and is growing really, really fast. Now, I don't know about you, but I'm very terrible at knowing what size clothing I am when I'm trying to buy clothes from an online store. So I also managed to make this demo in just 2 days, where I'm able to enter my height and then using body segmentation, understand the key measurements of my body to then automatically select the correct size t-shirt or clothing at checkout in under 15 seconds. And of course, the beauty about this is that all the execution of the model is happening in the browser, so there's no imagery being sent to the server side. So my privacy is preserved when I'm doing this too. Now, moving into other areas here, you can see one of my colleagues also had an interest in animation, And here she brought SVG characters to life with a pose estimation model in TensorFlowJS. And of course, if you can do this in 2D, you can also go one step further and even do it in 3D too. And this work by Richard Yee, you can try it out on the link shown on the slide, allows you to become your favorite avatar or superhero or whatever it might be, or character, and actually join a video call like that. And there's currently a big trend online of being like VTubers and all this kind of stuff. And TensorFlowJS allows you to actually control these characters with a regular webcam instead of having specialist motion capture hardware. Now, if you can understand depth in the scene as well, which we now can, you can also create effects like this, such as 3D photos, bringing a single photo to life and allowing you to get subtle differences in change of point of view. And of course, if you can do that, you can even enable things like imagery lighting, as you see here. And this is actually an early demo. This actually improved since I took this screen recording. And if you go to the link, you can try it for yourself, which is more accurate. But you can see here, because I know the depth of my human body, I'm able to cast light rays around it using WebGL shaders in the browser. And of course, there's generative models that you can have a lot of fun with too. There's a new model from Magenta called Tone Transfer that uses TensorFlowJS behind the scenes to essentially turn your voice into a musical instrument. So now, even if you can't play an instrument like a flute, saxophone, violin, that kind of stuff, you can hum the tune and it will match your tone and replay that generatively in the browser for you. So now everyone can be a musician, which is really quite fun. So I encourage you to try that out after the show. Now, everything you just saw on the previous slides was powered using one of our pre-made models. And this is really important because our pre-trained models are really easy to use JavaScript classes for many common use cases. In fact, here's the whole variety for you on one slide. So we've got things on computer vision, human body understanding, text understanding, sound recognition, and a bunch of other stuff that's coming out as well, like KNN classifiers. And essentially, you can use all of these in just a few lines of JavaScript code without being a machine learning expert. So even if you're not a machine learning expert right now, maybe you're new to the world of machine learning, you can go ahead and get productive really, really fast and take your first steps. And these can be used to drive many, many interesting projects, as we'll see in just a second. But first, I want to give you a little flavor for these pre-made models to get familiar with what kind of content can come back from them. And the first one is object recognition. This is using a model called Coco SSD. And as you can see on the right, it's able to locate in the image certain objects that it's been trained on. It actually can recognize up to 80 common objects, like these dogs here. And not only do we get the bounding box, we can also count how many. And that's, of course, the beauty of object recognition versus image recognition, whereas image recognition would know there's dogs in the image, but not how many or where. So this is slightly more powerful than that. So let me go ahead and just share my other tab here to show you this in action, because it's quite cool. So here I'm actually on glitch.com, which is an online website, which is like a integrated developer environment all in the browser. And you can run JavaScript in real time here, of course. And I can click on any of these images, and I've loaded the Coco SSD model, and in real time, I can get classifications coming back. And just from these images alone, you can see how we can see that the dog is near the bowl of treats. And you could very easily write some code to detect when the boxes intersect, and of course, then do something useful with that knowledge. And of course, this wouldn't be a good demo without having something live here. So if I enable my webcam, you can actually see me talking to you down below in the bottom left-hand corner there. Hello. And this is running really fast on my computer, even though I'm actually sharing my screen at the same time, which is using a lot of my GPU. You can see it recognizes me as a person with 90% confidence, which is really good. And of course, to reiterate here, this is really powerful because all of this is happening in the browser in JavaScript, no cloud-based services used, so no costs, and also, of course, my privacy is preserved as well. So that's Coco SSD. Let's go back to the slides and continue over there. Oh, need to press present again. Sorry, 1 second. There we go, good. So moving on, we've also got text toxicity detection. This is the exact model that was used by the company I mentioned just before, and you can pass to it a string, or a sentence essentially, and it will give you a classification of what type of toxic comment that could be, or maybe none if it's not toxic at all, of course. And we've got things like insults, obscene, threats, and so on and so forth. And that will allow you to very easily, without having to make your own model from scratch, be able to filter things in your web apps as you see fit. So maybe you're working on a chat-based application or spam comments on like a YouTube-like application. You can now filter those in advance on the client side without ever touching your server-side resources. We've also got speech command and audio detection. This is hard to demo live, but you can see here I was basically shouting out different words here, and it's highlighting them in real time. So you could very easily train your own version of this to listen for certain words or sounds, and you could then easily make something like a video player that can play, pause, rewind, start just by you speaking those words. Or alternatively, maybe you're trying to do something in preserving the world or something in a rainforest, and you can listen for the sound of a chainsaw, and when you hear that, you can trigger an alert to say that some sound has been heard in that region and be notified of that, so you can send the police to go and deal with it. Now, along with this, we've also got self-depth estimation, which is the new model that came out at Google I/O this year. And essentially, for a given image of a human face, like you see here, some kind of portrait-like image, you're able to get the depth map back, which you can then use for things like the 3D photos and the image relighting that we saw earlier. We've also got the face mesh model. This is just 3 megabytes in size, and it can recognize 468 facial landmarks, as you can see here on the GIFs on the slide. Now, what's really cool is that this is actually running over 130 frames per second on my desktop computer back at home. And it should be noted that that desktop actually has a previous generation graphics card. It's actually running on a 1070 NVIDIA GPU. So this is not latest gen graphics card, but still it's able to get 130 frames per second, which is really, really impressive, all in the browser in JavaScript. And we're starting to see companies embrace these technologies to bring their products and services to life too. On the right-hand side of this slide, you can see that L'Oreal, who's part of the Modiface group, have created augmented reality makeup try-on. And the key thing to note is that the woman on the right-hand side of this slide is not wearing any lipstick. We're using WebGL shaders combined with our face mesh model to overlay the shading on her lips correctly, so she can try on different types of lipstick without even having to be in the store or share a lipstick with someone else, which is very useful in times like we are right now. And this is a pretty cool model, so I just want to show you this live as well. And you can see here me talking to you, the new version of the model that just came out. And bear in mind, I'm running this on a very old Ultrabook. This is 5 years old. Doesn't really have a graphics card at all. It's just an onboard thing. And even with this, whilst I'm presenting to you at the same time, I'm getting a solid 26 plus frames per second. And that's really not too bad, considering this is a very old laptop. I can move my head around here. It's tracking my face pretty well. I can open and close my mouth and squint my eyes. I get really good granularity around the eye region as well. So you can imagine how you could use this to do many things. And some of you who are keen on the right-hand side will notice we can actually change the backends that we execute on, such as WebGL or the GPU on MediaTek GPU. So you can choose as a developer what backend to use, which will give you different performance benefits. One might be faster than the other, but the other might work in more locations than the other, for example. So you can choose that as a developer based on what your end users are using. All right, so back to the slides then. Let's go back over here and replay this slideshow for a second. Give it a moment to load. And we are in business. So on to the next model then. So in a similar way to the face landmark detection, we've also got hand pose estimation, which allows you to understand the joints of the hand, the skeleton of the hand, essentially. And this works across 2 hands, not just one. You can do 2 at the same time. And we can understand the 2D and the 3D points of this, which you can see from the animations on the right. So you can imagine how you could use this for human-computer interaction, touchless interfaces, all that kind of stuff, and even maybe sign language recognition, all via the browser, which can be very, very powerful. Now, linked to this, we've also got 3D pose estimation, and also it should be noted this can work in 2D as well, as you can see in the middle animation. And this GHUM 3D model can recognize 33 key points on the human body as shown. And this can run at over 150 frames per second on a modern desktop like my one at home, which is like 1070 GPU, which is actually previous generation technology, but fairly modern overall. And if you're running this on a phone or something like this, you can still get close to 60 frames per second on a new generation phone as well, which is pretty impressive. So if you're looking to understand the human body, you can imagine using this for sports, fitness, even healthcare, like you saw before. You can now do that in the browser and have zero install, which is really, really powerful. Now, linked to this, we've also released recently a full body segmentation model that builds upon the pose estimation model you just saw on the previous slide. So here you can now, for every pixel in the image, segment it in real time to understand what's the body and what's the background. Now, with that understanding, you can, of course, create things like removing the background, blurring the background, or even removing the people from the image. So depending what you want to do, you can achieve all of that very easily with TensorFlowJS. And of course, linked to this, we've got a specialist version of this model for selfie segmentation, which is actually used in similar things like Google Meet, for example, to allow you to replace your backgrounds. And this has finer granularity around the upper half of the body, as you can see here. So do check out the links on all these slides if you want to learn more and try them for yourself, as they are just going to run in the browser. So we've got lots of live demos for you that you can try all for yourself in your browser. Now, with a bit of creativity, you can, of course, push these to go much, much further. And I just want to go through some superhero powers that I made to just inspire people that are quite fun to get a gist of it. So the first one is Invisibility, and this is using an old body segmentation model, which was actually made a few years ago, but you can imagine replacing it with the one I just showed you to get much better granularity around my body and much faster speeds. But notice as I move on the bed deforms on the right, but my body is removed. So you get this really cool ghostly effect. And this is a fun example, but it could be used for the movie industry or something like this. We want to remove moving people from the scene to make it look more empty or something like this. We've also got lasers. This guy decided to combine our face mesh model to give himself kind of superhero powers for lasers. And of course, if you're working with the movie industry or something like this could be a fun one to bring those people to life for the fans or something along those lines. And it does happen from time to time. I've actually worked with Hollywood and other people in the past to do these kinds of activations. So this is kind of cool to do in the browser that everyone can just try out with a click of a link. And then I thought, well, it'd be kind of cool to do teleportation too. And using the body segmentation model, I'm able to segment just my body from my bedroom, transmit just the segmentation, and then using WebXR, which is a new emerging web standard, I can actually then place myself using a mobile phone in a physical location. And as I move the mobile phone around, I'll stay put, and I can kind of hear myself in the correct location and all that fun stuff. Now, again, this is using the old body segmentation model. The new one would be much more fine granularity around my body. So ignore those white blotches. That is not an issue anymore these days. This is using an old model. So maybe I should upgrade this. Feel free to check out my GitHub code if you feel like upgrading this to the new model for me. And essentially, this could be the future of communication, especially if you're wearing AR glasses. You can imagine summoning your friend, positioning them somewhere in your room whilst you're doing some other task, and then get on with your daily life as you need to, while still having a presence of your friend nearby you. And of course, this can be used with other technologies as well, as you see here. And this guy is using 3.js and WebGL and all this fun stuff to kind of bring characters from magazines to life, to literally bring them from the magazine in real time into the room to then inspect the fashion or whatever it might be that they're interested in. Now, of course, if you can do all this, you can also do things like face masks for Halloween. If you understand the face of an image, where the face is in an image, you can then take that out and overlay it on the face in the webcam stream in real time to give you this ability to kind of wear any mask that you like. And of course, human-computer interaction is on the rise as well. And we're seeing a number of companies around the world try and use our hand models and body models to perform human-computer interaction. So I think this is a really interesting space for everyone to start looking into to see how we can improve our quality of life using novel input devices like this for games, for interfaces and kiosks in high traffic areas, that kind of stuff too. Now, there's also some fun things along artistic lines to bring paintings to life, like the Mona Lisa here, which someone used traditional TensorFlow in Python to generate the images, and then face mesh to control where their face is in the scene. So the character then follows you around as you move around to give you that kind of effect that is noted with the Mona Lisa, that her eyes tend to follow around. But this one actually blinks as well, which is an extra cherry on the cake there. And I want to also point out that don't forget that as JavaScript engineers and web engineers, we can also integrate with hardware. There's emerging web standards for Web Bluetooth Low Energy, Web Serial, Web USB, and with those connectivities, you can actually talk to hardware, as you see here. And this is a Kickstarter that someone made that allows you to track your sporting videos So the person's always kept in the frame using TensorFlowJS on a smartphone and a device over Bluetooth Low Energy. So pretty cool. And just want to remind people that hardware is possible too. Now, you might be wondering at this point, you've seen a lot of cool examples, but how hard is it to use all these pre-made models to make these things, right? So here is an example of using our Q&A model in the browser. And this essentially is a Chrome extension that allows you to ask a question and scrolls you to the part of the web page that answers the question. And note here that I asked the question, what are the best stargazing days? But note that in the answer, stargazing is not mentioned at all. So this is a really good example of natural language processing. This is more than a control F to find the keywords. This is understanding the text on the page. So let's see how I made that, really. So in just a few lines of code, you can actually make this yourself. So first of all, at the top here, you import TensorFlowJS for library. And then below that, you import our Q&A model. So this is one of the pre-made models you can import. If you want to do something else, you just grab the reference to that instead. But if you go down to the JavaScript below, the first thing, you've got two strings. The first one is the search text. So you can imagine this to be all of the text on the web page. But here, I've just got a short sentence to keep it on one slide. But you can imagine you could scrape the text from a web page as the search text. And then you've got the question, which is the question from an input box that the user wants to ask. Okay, just like you saw in the demo on the previous slide. You then can load the model because you imported it above. So you can do Q&A.load. And because this is an asynchronous operation, it will take some time to load the model, might be a few megabytes in size. You use the then keyword in JavaScript to wait for that to come back, which will pass to you a model variable, which contains the model itself that's loaded. And once that is loaded, you can then call model.findAnswers. You pass to it the question and the search text from above. And again, this is an asynchronous operation. It might take a few milliseconds to execute. So you use the then keyword once again, and that will call a function of your choice back with an answers object, which you can then iterate through. And of course, if you run this code on this slide right here, you should get the answer cats, which of course is the answer to what's important on YouTube from the context of this slide. And that's all there is to it. So our pre-made models are really easy to use, and I encourage you to go try them all out after the show. Now, if you are a bit more advanced, you can also look into transfer learning to work with your own custom data. And a really good example of this is a website called Teachable Machine that actually uses TensorFlowJS to do just that, live in the browser. So we can retrain a model live here today. So let me go ahead to teachablemachine.withgoogle.com. And when you go there, you'll be presented with a screen like this. If I click on Image Project and set the standard image model, you'll then get a screen that looks something like this. And here on the left-hand side, we can now choose what classes or object we want to recognize. So I'm going to do this live here today. I'm going to put Jason as the first thing, as I'm in front of the webcam. That's easy to recognize. And then I'm going to put my hand as the second one. So we're going to enable access to the webcam. I'm going to capture some example images of Jason's, which is me live here today, of course. And hopefully this will load in just a second. There we go. I'm going to click hold to record to get some variety of my heads moving around. And you can see there, I've got 35 sample images. I'm then going to do the same for the hand. And here, I'm going to just get roughly the same number of images of my hands, 30, a bit more, maybe 36, that's close enough. And the reason I want to get the same number of images is to avoid any bias in my model. If I have 100 hand images and only 30 JSON images, it might just learn to predict hand over time and be correct 70% of the time or something like this. So, you want the same number of images to avoid that situation. We can then click Train Model live in the browser. And now TensorFlowJS is going to take a mobile net model and retrain it live in the browser for us, just retraining the top layers based on all the knowledge it's already learned to learn what JSONs and hands are instead. And again, bear in mind, this is working on a very old computer. This is a 5-year-old laptop I'm using today. But in less than 30 seconds, we've got that trained. And you now see a live preview on the right-hand side. And you can see here it's predicting JSON with 100% confidence. If I move my hand into view, it says a hand, 100% confidence. JSON, hand, JSON, hand. And look how fast that works. It really responds in real time. And that might be good enough for you for a prototype. So if that is, you can click on Export Model. You can click on Download. And you can then copy this code to have some boilerplate code to work from. And of course, you can download the model.json files above, which you can then save and host on your websites. And with that, you can then make your own UX around it, make it look really pretty, and make something really useful. So maybe you want to recognize your car, or maybe you want to recognize your cat, or whatever it might be to feed it a treat. All of this is possible. And you can imagine using a Raspberry Pi with a servo to then feed your cat a treat or do something interesting like this. So that's Teachable Machine and is powered by TensorFlowJS live in the browser. Everything you just saw happened in JavaScript in a browser. No cloud-based service was used to train that model. It all happened in JavaScript. All right, let's go back to the presentation. Jolly good, and click on the slideshow here. Now, Teachable Machine is great for prototyping really fast, as you just saw, but if you want to move to a production-based model, you're going to need more data. Now, if you're experienced with machine learning, you can use TensorFlowJS in Node to do that, which we'll hear more about in just a second. However, if you want an easier approach, there's also Cloud AutoML. And you can see here, someone's got gigabytes of files of flowers that they want to classify, and they've uploaded it to Google Cloud Storage. You can then click Next and choose to have higher accuracy or faster prediction times, and Cloud AutoML will then try and train a model for you that will work well with that data set, given those constraints. And then a few hours later, it'll come back to you and ask you how you want to download the model. And there's an option to download the TensorFlowJS, as you see here on the slide. And just like before, you can then use that in just a few lines of code. And this is very similar to the one before. You import TensorFlowJS, you import the Cloud AutoML script. And then here we've got an image that we want to classify. So here's like a daisy.jpg that we've brought in from the internet somewhere. It's got an ID of daisy here, as you can see. And then the JavaScript here is just 3 lines of JavaScript. We wait for the model to load by calling tf.auto.ml.load image classification. We pass to it the location of the model.json file you would have downloaded in the previous step. That's hopefully hosted somewhere on your web page. And when it's loaded, you can then grab a reference to the image you want to classify. In this case, it's the daisy image. And then we can call model.classifyImage and await for those results to come back, and then go through the predictions and do something with those once you see what they are. And that's really all there is to it. Production quality ML in the browser. Now, the third way to use TensorFlowJS is to write your own code, of course, and I've got a whole course on that to go into details on how to do that. So here's an overview of why you might want to do that. First of all, our APIs are very similar to what you might be used to in Keras. So if you use our layers API, that essentially replicates what Keras does. It's even got the same or very similar function definitions, but with a JavaScript spin. And that's very high level, which is what our pre-made models are built upon. We've also got our low-level ops API, that's more mathematical. If you want to go to that level and kind of get down and dirty with the linear algebra and all that kind of stuff, you can do that and make new high-level APIs from that too. So here we go, then putting it all together, we've got our pre-made models that sits upon the layers API. The layers, it sits upon the core or ops API, and that understands how to work in different environments, like the client side in the browser. Now, in TensorFlowJS, we have a concept of backends, and by backend here, I do not mean server side. I actually mean the hardware it's going to execute on. So this is an ML-specific terminology, even though we're talking about front-end technologies. And the backends here you can see on the front end are supported as follows. We have the CPU, which is essentially vanilla JavaScript, which is the slowest form of execution. We've got WebGL, which allows you to get faster performance on the graphics card, essentially using computer graphics to do mathematics. Very cool. And we've also got WebAssembly, or WASM for short, which allows you to get faster performance on the CPU by executing assembly code in the browser. And TensorFlowJS supports all of those backends to run very fast in the browser, as you've seen. And in the future, you can see here, in addition to the 3 that I just spoke about, we're also working on investigating WebNN, which stands for Web Neural Networks, and also WebGPU, which we just actually announced an alpha for in our Google I/O presentation this year. So do check that out if you're interested, as it can run faster than WebGL, in fact, in some circumstances. Now, if you're going to the server side, of course, you can use Node.js to run TensorFlowJS models. And the key thing to note here is that Node.js is just like Python in the fact that it's just a wrapper around the C++ core, which is what TensorFlow itself is written in if you're running on the server side. Now, that means you get the same TF-TPU and TF-GPU bindings for AVX and CUDA acceleration if you're already using stuff over on the server side. So that means Node is just as fast as Python, and in fact, in some cases can be faster than Python, as we'll see in just a second. Now, if you do prefer to stay in Python to train your models, that's completely fine. Our layers API on Node.js allows you to load saved Keras models, and our core or ops API allows you to load saved models without any conversion. So this is really important to note, that if you are staying on the server side, you can still integrate with JavaScript developers via the Node ecosystem on the server side without needing to convert your models at all. Now, if you do want to convert your models to run in the client side to get those benefits I spoke about earlier, like privacy, then you need to use our command line converter to convert that Python saved model to the JSON format that I just spoke about that can run in the browser. So let's look at performance very quickly then. You can see here TensorFlow Python versus TensorFlow Node, and it's basically 1 millisecond of difference. It just depends what the server is doing in that moment, honestly, not a lot of difference. However, if you have a lot of pre and post processing in your model, you can see here Hugging Face, who are very famous for natural language processing models, actually converted by the Stillbert implementation to run in Node.js. And it led to a 2 times performance boost over the Python equivalent. And that's because of a just-in-time compiler of JavaScript that's unique to JavaScript that allows it to optimize at runtime. And that means it actually ran really, really fast with all that pre and post processing. Now, if you do want to stay on the server side, there are some benefits to doing that in Node, of course. The first thing is that it allows you to use the safe models route conversion, allowing you to integrate with other JS developers. You can run larger models than you can do on the client side, because obviously you don't want to push gigabytes of data down to the client side on a tiny mobile phone. That wouldn't be wise. And it also allows you to code in one language. As you already saw, over 68% of developers do use JavaScript. So even if you're not, it allows them to take your models and use them in a much more scalable way. And of course, you've seen that the performance boost you can get from Node is significant. Now, if you switch to the client-side superpowers for just a second, the first thing you can get, which is impossible on the server side, or very hard to achieve at least, is privacy. So that means, of course, all the model execution, the inference, actually happens client-side in the browser, which is very important if you're working in healthcare, legal situations, or even in Europe where they don't need to transfer stuff to other servers. This can be very beneficial, and you get that for free with TensorFlowJS. You also have lower latency because you're not talking to a server. There's no 100 millisecond round trip time to ping the server and wait for a response to come back again. That's now not there. So you can go hundreds of frames per second, as you saw in the demos before. This can all lead to lower cost because you're not having to hire expensive hardware in the cloud, like GPUs, RAM, CPUs at scale. And if you've got a reasonably popular website, that can save you thousands of dollars per month. And the fourth point, interactivity. The web was designed from day one to be interactive and have shareable content. For that reason, there are far more mature libraries for computer graphics and visualizations and graphical user interfaces than other languages. And you can do in days what might take you weeks in other locations. And then the fifth point is the reach and scale of the web. Anyone, anywhere can open a link and try that machine learning out. And that's a really important point because if you're working in research, you want more people to use your models, but currently there's a big barrier. So let's look at more into that. So why is research in JS an important topic to cover then? Well, currently, if you have a cutting edge model in TensorFlow Python and you want to try it out, you're going to do something like this. First, you need to understand and install Linux. Then you install the CUDA drivers, you install TensorFlow, you clone the GitHub code, you read the documentation, hopefully the documentation is good, and then you install the dependencies. And then if everything is on your side, it might just work. And I'm sure we've all been in the situation where we take a deep breath and hope that everything works. And it turns out that very few people have the knowledge and time to do all of this in the grand scheme of things. Most developers don't. And it'd be much easier just to have a very simple web path where you just visit a website and the cutting edge research works for everyone to try out and experience. Now, currently, there's a lot of people out there who do want to use machine learning, including the new models, and they understand how they might want to apply it, but they just can't access it, as illustrated by this slide. So if you convert this to JavaScript, those people can then actually try it out in their niche applications, which might be something you've never even thought up before, applying maybe body segmentation to remove a body from the scene instead of adding things around it. And that, of course, will encourage feedback to come back to the researchers, which allows you to find bugs and biases that you didn't even know existed, which allows you to make better models that in turn go back out to the community. And this is in fact how we're working at TensorFlowJS, and that's how we've developed some of our pose estimation models in collaboration with the healthcare community, as you saw at the beginning of this presentation. And this allows us to create better research longer term for all. Now, I want to end this presentation with some resources you can use to get started if you found any of this inspirational today. Essentially, I just released a brand new course that takes you from zero to hero. You need zero background in machine learning to take this course, and it's completely free over on edX.org. Check the link there to sign up for free and take it. And it'll get you very productive in using machine learning. You can learn how to use our pre-made models, how to do transfer learning, how to write models from scratch, how to convert from Python. All this stuff is available in this course. You can also check out our tutorials on codelabs.developers.google.com, and you can search TensorFlowJS there to find all our kind of niche code labs that you can also try out, like making your own smart webcams, spam detection systems, and much more. And of course, if there's one side you want to bookmark this is a good one for you. Essentially, the first link there is our website for all the juicy details about TensorFlowJS. The second link is our models repository that you can click on all the models and try them out for yourself. We are completely open source, so we're available on GitHub, of course, and we encourage contributions from the community if you have the time to do so. We do rely on contributions from you guys to also contribute to that as well. If you've got more technical questions, we've got a forum, discuss.tensorflow.org, where you can tag your post with TF.js so that our team can find it and help answer those questions. And if you want to get started really fast with some boilerplate code, we've got examples on CodePen and Glitch, like some of the demos you saw today, that you can fork in minutes and then have a working starting point to go from with the webcam and all that kind of fun stuff. I've also got some inspirational videos on our major TensorFlowJS playlist over on YouTube, which are fun 10-minute bite-sized interviews you can watch to get inspired and even find others from the community to hack with. And we've got a bunch of people on there doing some really great things, all the way from self-driving cars to things that can dance with you and many, many more things beyond that. If you prefer to read a book, we've got some books that I recommend there. If you're new to machine learning, check out O'Reilly's Learning TensorFlowJS. And if you are more experienced, check out Deep Learning with JavaScript. That was written by some of the folk on my team and goes much deeper into the nitty-gritty details of that machine learning and some of the thoughts behind that. So do check out those two books. Also, if you are inspired by anything you saw today and would like to represent TensorFlowJS in your regions, I'm looking for people to work with around the world to help spread the love in talks just like this in your local regions, maybe in your local languages as well, to help make that more available to people around the world. So if you're interested in doing that, come talk to me after the show on LinkedIn or Twitter, and we can figure something out. So the only thing left to say at this point is come join the community. Do check the hashtag #MadeWithTFJS on Twitter and LinkedIn to get more inspiration, or if you make something, use that hashtag for a chance to be featured on our future shows and events. And with that, the last thing I'll show you is a guy from Tokyo, Japan here, and he's actually a break dancer by day, but even he has managed to use TensorFlowJS to make this really cool hip-hop video. And my point for ending with this is that machine learning really now is for everyone, and I really hope that TensorFlowJS can be part of that story. No matter if you're an engineer, a designer, an artist, a musician, it doesn't matter. Machine learning is for everyone, and I look forward to seeing what you all make. So do use that hashtag if you do. And with that, thank you so much. You can connect with me on the left-hand side there on Twitter, LinkedIn, or Discord, and of course, some of the popular resources on the right-hand side there. I think we might have some time for some questions, so feel free to go for that now. Thank you.
Thank you, Jason. Amazing presentation. I feel my love getting back to TensorFlow again, so I really inspired to try it out. We don't have a lot of time, but there is one question which I want to ask you is, are there any difference between Python and JavaScript APIs in TensorFlow in sense of the available functions and methods, or are they mutually replaceable?
Yes, so we tried our best to replicate the most common functionality from Python in JavaScript. However, we are newer than Python, so there will be some things that don't exist in JavaScript yet. But that's why we're also looking to the community to help us port some of that stuff over as well. We're a smaller team right now, but growing very fast. I hope with time we'll get more parity. But yes, there will be certain things that you might not find in JS right now. But if it's something you need and is very valuable to the wider community, please let me know, and I can try and put that on our priorities in the future.
Thank you. Thank you. And probably one more question is, does using TensorFlowJS in a browser web apps impact performance a lot?
Yeah, so of course, in the browser, you're running on the client-side device, so it depends on what device you're running on. So if you're running on a smartwatch, of course, the performance on that's going to be very slow compared to, say, a cutting-edge desktop or even a laptop, right? However, on smartphones, most of the models you saw today can run at over 30 frames per second fairly easily with our newer models. And if you're running on a desktop, you can get hundreds of frames per second. So the bottleneck is actually your web camera keeping up with the frames per second, not our models these days. However, that's going to increase with time, so improve with time with things like Web GPU coming out, things that are only going to get faster as well. So I look forward to seeing where that goes.
Thank you. Thank you, Jason, for this amazing presentation. Thank you for joining this conference, and thank you for supporting Ukraine. For everyone who's watching, small reminder, Jason will be in breakout rooms, so you can ask any questions, anything you're interested. And we want to thank you again, Jason, for this amazing presentation.
Thank you so much for having me, and look forward to speaking to you in the breakout room. Thank you.
Sure.